What is the second degree Maclaurin polynomial of f of x equals natural log of 1 plus 2x? Okay, so first thing you think of, Maclaurin series is just a Taylor series. And a Taylor series is a formula of something sort of like this. That's an N. I can do that better, you're right. Nope, that's a terrible line. There we go. My drawing skills are not strong today. Not strong. Okay, so this is the formula for a Taylor series, and a Maclaurin series implies that A equals 0, which is the most common kind of Taylor series you want. And second degree means that N will equal, so for this it'll be 0, 1, 2. And yep. So this is of the natural log. So we're going to have to find some values for natural log. And you'll notice here that it has a 1 there. And when you find like a Mclaren series for natural log, you'll a lot of times see a 1 there because they're trying to avoid taking the natural log of 0. Because natural log of 0 doesn't exist. Negative infinity. And it's a similar idea of dividing by 0. You just really shouldn't do it in life. Kind of ends mathematics as we know it. So that's why that 1 is there, not coincidental. Okay, so now we're just going to start finding values. So f to the 0, this is the derivative up here, to the 0th derivative of x equals natural log of 1 plus 2x. Seems reasonable. Therefore, f of 0, since this is a Maclaurin, equals natural log of 1, which equals 0. Yes. And then we know that the next term is going to be x to the 0, which will equal 1. And then we'll have 0 factorial, which we're not going to write down because we can remember that. Okay, next we're going to do the first derivative of x, which in this case will be the, let's see, this is going to be a chain rule. So we'll do 1 over 1 plus 2x times the derivative of the bottom, which is 2x, which will be 2 over 1 plus 2x. Yep. That x shouldn't be there. Okay. And therefore, f prime of 0 is... Think. 2. There we go. Then x to the first will be x. Then that's really x minus 0 to the first. But since it's a Maclaurin series, which is why the 0 is there. I just left out the x minus 0 part because 0 is, well, it's important, but not important in this case. And then we do the same thing with, I'll write a 2 there for the second derivative. So we'll take the derivative of this, which is 2 times 1 plus 2 to the x, 2x to the minus 1, which is, we'll do the power rule here. So we'll do 2 times negative 1 times 1 plus 2x to the negative 2, which then gives us negative 2, 1 plus 2x squared, f double prime of 0. I know I used 2 over here and double prime here. Inconsistent. Negative 2 over 1. So it'd be 1 plus 0 squared, which is still 1, which gives us negative 2. So we have 2 and negative 2. And then x squared will be x squared. Okay, so now we should have all the data points that we need. We're going to want to know this, that, and this. So write out the first term will be the 0th derivative f of x, which we know is going to be 0. 0 times 1, so it would be 0 times 1 over 0 factorial. 0 factorial is 1. That's the 0 times the 1 is going to be 0. So that's going to go away. Plus 2 times x to the first, all over 1 factorial. So 2 times x over 1 factorial plus negative 2 times x squared over 2 factorial, which is 2. So rewriting this a little bit simpler, change to green to add a little contrast. So we have 2x minus 2x squared over 2, which equals 2x minus x squared. And I think that's about as simple as it's going to get. Try and highlight that, move it over towards the answers. Ah, I see what probably happened. Okay, so click, click. So here, when I took the derivative, I did the power rule, but I should have done the power rule and the chain rule. So if you see right here, this 2, I should have multiplied it by 2 there, which would not give us negative 2, but give us negative 4. And so this would be negative 4, and what we'd have here would be negative 4 divided by 2, 4, and would give us 2x minus 2x squared, which would be that one. See if there's any other answers. Yep, I think that was the mistake I made. Gosh, so many mistakes. Quite careless. Okay, so to backtrack, this is a difficult problem. If you get something like this in the AP test, you're gonna have to move through it pretty quickly. I know I'm pretty lackadaisical when I go through these, but that's because it's more of a learning than a testing type environment. You should have all the same thoughts that I'm having, but instead of having a thought spread out over 10 minutes, you have it spread over like 2 minutes. So the idea with this one is Maclaurin Series. Okay, Maclaurin Series is a type of Taylor series. A Taylor series follows a formula like this. You write out the values for each of the terms as best you can. You know, granted, it has a lot to do with how much time you have. It could be the sort of thing where you write out, all right, first derivative, looking at this, it's going to be a natural log of 1, it's going to be 0. Okay, that can go away. And you don't even bother thinking about that anymore, and you just move on to the next one. You write out your terms, you find the derivative of each power you're going to want, and you plug in your value of A. Evaluate your terms, and don't forget to divide by the factorial, and put it all together, and you get your series. And that is a general idea of how you do a Taylor series, or in this case, Maclaurin series type problem. You won't get too many of these in the AP test, especially not in the multiple choice section. You'll get more in the free response because you have a little bit more time to go through things. But you will get problems maybe this complicated, but probably a little bit easier for multiple choice. And it's not really a difficulty issue, it's just a time going through all the steps issue. And with that, wish you the best of luck on this type of question.